Hello and welcome to another edition of Code Remix Weekly. I'm your usual host, Sam, and our presently unusual host, Tim, is not here in the present. I'm not sure what he's up to this week, but I will be asking him that next week when we are at the Code Remix Summit in Miami, which we will be doing in not having a live stream. Although it might be fun to have a brief live stream at the conference. We're not really planning anything there, but I don't know. Maybe we could turn it on for a minute and just chat with some attendees. We'll see. Maybe there'll be an unscheduled guerrilla live stream that only those of you who checked out this intro will know anything about in advance. Or maybe not. No promises. Anyway, for this week's announcements, we have not all that much, except that we are announcing C# support in Open Rewrite, both in terms of a bunch of recipes that already exist and the core parsing technology. There's a C# SDK with a whole bunch of recipes to do various things. So basically all of the things you can use Open Rewrite for in the Java ecosystem, you should now be able to use in the C# ecosystem as well. And I might have to double check, but I believe it should be possible. Yes, you can write your recipes in C#. There is a remote procedure call mechanism that allows the Java process running a recipe to, or running the whole recipe run to call out to C# recipes and pass information back and forth. So you could write a recipe that manipulates C# in C#, or you could write it in Java. And you could have both in the same recipe run, modifying the same LST. So yeah, I encourage everyone who might have some interest in C# to check out this blog post. Let's see. Aside from that, we've been putting out releases of Open Rewrite, like this one just 9 hours ago, that still had several bug fixes in it. And that has been, let's see, I guess in the past week since we last spoke, there's been 1, 2, 3, 4, about 4 releases of Open Rewrite since last week, with a lot of fixes for Groovy things, Java things, C# things, JavaScript things, really oriented around language expansion. Although one thing that did go into this release that might be of general interest, or in these recent releases that it might be of general interest, is some performance improvements that I made to the dependency manipulation recipes. Looking at the data in the large migrations, like the Spring Boot migration was taking like 4 minutes on a repository with 1,000 files, which is a little slow. And when I looked into it, I saw that it was the checks for the presence of types, where like a recipe like add dependency would run, and it would only run if a particular type was in use, a common feature of that recipe. And this feature was used to, avoid adding unnecessary dependencies. But within the whole of the Spring Boot migration, there were like hundreds of those recipes that were doing that check. And so I made that faster by building some caching into types in use for type lookups, which is tangentially related to the topic that we're primarily discussing today, which is a feature that I'm working on in the CLI. And so this is not released yet. So here's a preview that I'd be happy to hear anybody's feedback on or questions about, or suggestions for how to improve, which is a mod test command. And the idea here is that, normally in the main Open Rewrite build, if I build, this should take about 10 minutes on my powerful local computer. But if I am looking at us on CI, the full Open Rewrite test pass has gotten real long. I remember back in the day when it was only 10 minutes or so to run on CI. These days, a CI build can at the worst case can take up to like almost 50 minutes, right? If you run something where it has to run all of the tests, it can be quite time consuming to run everything. And I don't know about you guys, but I'm really seeing the number of tests in code just in general shoot up as people use coding assistants. I am seeing that humans find tests kind of tedious to write and even tedious to read. Um, so so when it's people writing the test, they don't write more of them than they absolutely have to, right? But now that you have coding assistants doing a lot of the test writing, the coding assistants are adding tons of tests to every code review, every patch or pull request you work on, and often the human engineer and code reviewers, much like someone reading an end user license agreement, kind of scroll to the bottom and click accept if all the new tests that were added are passing. So I'm seeing an increase, a proliferation in the number of tests that are out there, and which translates directly into an increase in time spent running tests, an increase in time spent on CI. So, just looking through like some recent open rewrite, like CI runs, there's this one failed, but of the successful ones, we have a lot like 20 minutes, some that are as low as 5 minutes, 12, 17, 23, 30, 19. So, Gradle already has some up-to-date checks built in. So if absolutely nothing has changed in a module, it can be good about skipping things. But it's easy to get into a situation where you have a 36 or even a 50-minute full build was kind of the worst I'd seen on here, which is a long time to wait. So I got the idea and I just kind of want to see this run so we have a baseline on my local machine. I expect this to take about 8 minutes, but we'll see. So I figured, well, we could potentially do better than that with the information that's in the LST. We could potentially tell more specifically which tests need to run for any given change. So what I have been prototyping is a mod test command that uses a variation on the find call graph recipe first it looks at what files you have open in your Git workspace, and I have a couple modes for this, but the basic one is to look at unstaged files. So right here I have some changes that I'm looking at, or I'm currently checking out ways to further improve the performance of our dependency manipulation recipes, and so I have some changes open for like Maven resolution result, potentially adding a cache of what coordinates are in it, so that to speed up lookups because many recipes will have to ask the question, does this POM have this dependency? And right now, a lot of recipes answer that question by just like iterating through all the dependencies in the POM. And so if you have a project with 20 POMs and you have a big migration recipe, like the Spring Boot migration, you might have hundreds of recipes looking through hundreds of dependencies, each looking for one they want. And so I'm trying to make those dependency lookups faster. So this is some in-flight work that I have, open and not checked in. And there's currently some tests failing. We're about 4 minutes into this full test pass here. Looks like we're at rewrite Gradle, which is towards the end. So this might end up finishing up in about 5 minutes to run everything. So this should be getting done pretty soon. So it's the basic idea of the mod test command, which I'll demonstrate as soon as we have this run done. So something to compare to is that we look at the files that are open in the repository, and then we use the output of the find call graph recipe to connect files that have code changes to tests that exercise those code changes, even indirectly. Although I'm still thinking about what we'll do for cases where you have like reflection or dependency injection. So right now it's based on like statically verifiable links between the code that has changed and tests that are in the project. And so I will show that in just a minute. The idea being that you should run only the tests that verifiably have something to do with the code you actually change, right? If I just change a single class, I don't need to run all 100 test classes if there are not any links between the class that was changed and those 100 test classes. And part of the idea here is that this could also be a useful agent tool. I've certainly had the experience of having Claude, guess at what tests are applicable, right? It can usually figure out that the test class that corresponds most directly to a class, class name plus test, it will usually guess exists, and it's usually right. But then beyond that, it usually just jumps right to running all of the tests in the project with no more intermediate step, and so we could potentially have faster iteration cycles, both as human engineers and as agents, and potentially save some resources on CI if we tested only those things that were actually changeable. So I'm going to give this a minute or two to run. I expect this to finish at probably around 9 minutes, which means I have to flap my gums a little bit more before we can exercise mod test on this and get a comparison. Well, I guess I can go ahead and show you a test plan. So the idea is that the mod test command has two phases: one where it generates a test plan, and a second where it executes the test plan. And you could do one or the other, or both at once is fine. Like if you just do mod test, it's going to generate a test plan, and then it's going to run all the tests in that test plan. If you do mod test dry run, it's just going to generate a test plan without running it. And the test plan takes the form of a CSV. So like here is a test plan that I have generated for these changes that I showed you, where I have, this package lock.json has some changes in it just from running the build process. And then there's some changes in Maven Visitor and Maven Resolution Result and Maven Parser. So what the idea of the test plan is to make links between this to all of the tests that exercise these things so that we can, cover just that. And so here's a test plan that mod test came up with that I produced in advance, and I'll show you running this in a moment, where it has listed out a bunch of test classes that are potentially relevant to these changes. And then in the path column, it has listed one of, not necessarily all of, but one of the paths from a test class or from a method in a test class to something we have changed, right? So this no system dependencies test uses the assertions POM XML, which references Maven Resolution Results, which references Maven Visitor. And so that is what is bringing almost all of these tests into this area. And this is kind of what I would expect, right? If I've changed Maven Visitor, if I've changed Maven Resolution Result, these are things that are broadly relevant to all of the Maven tests. And maybe in a minute we could try doing a different set of changes and seeing what comes out of that. But we have an example of one that's a little unexpected, is that a change to Maven Visitor is calling out that this org.openrate.gradle.search.find Gradle project test might have something to do with that. And so I looked at this one thinking, hey, is this a bug? But if we go and look at this find Gradle project test, it actually does have a negative test case in there that says, hey, find Gradle project specifically should not match a Maven project, which of course calls this pom.xml function, which of course has a touch point to Maven Resolution Result and Maven Visitor. So yeah, you kind of, hopefully that is kind of showing the concept so you can see the vision. Let's see how this is doing. Okay, cool. So, there's some failing tests, but for our purposes right now, that's fine. This is work in progress. Although, so some failing tests is just some stuff that might have to be dealt with before we run. So I will show you the mod test command. So So if I want to generate just like the test plan I showed you a second ago, we can run this mtest dry run command, which is going to take some time to run that find call graph recipe over all of the sources to establish those linkages I talked about. And so this is kind of not exactly a one-time cost, but a cost you only have to pay when you've like changed when you make a change to your change set, right? Like if the relationships between the classes you're working on and the rest of the code base haven't changed, you could generate a test plan once and then reuse it many times throughout the process of development so this could be a cost that you would have to pay infrequently. And I'm thinking about how to make even this faster, because taking a minute to figure out these relationships to run fewer tests, we kind of have like a 9-minute budget we're working with, right? This whole process has to be faster than 9 minutes or 16 seconds, or it won't be worth the trouble of going down this route. But yeah, what's going on here is it is figuring out those linkages between the sources I have changed and all of the tests that cover it, and spitting out a test plan, much like identical to this one that I've just shown you here. And we shall let this go just to see how long it takes. And we'll try running it. And we're making it through a bunch of sources. And then if we've generated the test plan, we can run it. And I can show you how that works. All right, cool. So we generated a test plan, and that has, this is identical to what I just showed you, but that's where you get that from. Now, if we want to run it, we can ask test plan to invoke the most recent test plan. And so what it's going to do here is it has generated a very long Gradle command line that specifically runs Gradle within an init script, which is used to report back, or which configures it to report back to the calling process, so that we can display some stuff on these progress bars. But basically, we get this long command that lists out all of these test classes that we want to run explicitly, and then ask Gradle to go do that. And then the Gradle build goes and runs just those test classes. So let's see how long this takes in total to run just the small set of tests in Rewrite Maven, and that one test for Rewrite Gradle that provably had something to do with the changes that were in flight. So we're up to change parent POM test. So long as this finishes in under 9 minutes, then the actual running of the test part could be faster than just running all of the tests. And so long as it fits in under, we've got almost 2 minutes of overhead to create the test plan in the first place, then the whole thing would be faster. But yeah, again, you could use one test plan for multiple passes. If you're not changing things, you don't have to regenerate the test plan every time that you exercise stuff. And so this test plan could also just be an artifact that is something that's useful to your coding assistant, right? Maybe you don't even use mod test to exercise it, but you just use it. You just tell your agent, hey, look at this test plan to figure out what classes are relevant to the changes, and keep that in mind while we're working, so that we can have faster iteration cycles without having to run all of the tests, and so that we can focus on only the ones that matter, but get that better coverage. I know that you have, or I have certainly had the experience many times of Claude being like, I'm done, the tests pass, and then the broader set of tests don't pass. Only the one unit tests that it had figured out were relevant here. And so here we go. So we're finished, and we finished this run in 2 minutes and 24 seconds. So the kind of total time here is 4 minutes and 20 seconds or so. So roughly half of the time spent on running the full test pass is enough for us to generate the test plan and run just this set of the 1,000 or so tests that are relevant to this change. And, we get the same, because we are still using Gradle under the hood as a test runner here. We still get the same, the same reports that it normally produces for any other run you do. If you're using Gradle Enterprise or something, you'd still be a Gradle Enterprise link in there. But since you don't necessarily need to regenerate the test plan itself every time, once we have it, we could just reuse this. We could just reuse this over and over for a 2 minute and 20-second test pass that is about a quarter of the time of running the whole build. So this isn't, like I said, this isn't available in the Modern CLI release yet. I mean, you clearly see I'm working on a snapshot build that I'm building from source. So this is kind of a preview of what I'm working on. And we'll hopefully be getting this into the Modern CLI for people to use pretty soon. The idea is that we make it useful for our own builds first, and then kind of share it with everyone. And so, keep an eye out for that. And since it does need some build tool integration, right? Since it's going off and kicking off some other build tool to run all of the tests, I need to make sure this kind of has covers all of the different testing tools that are in use. So I started with Gradle and Maven in the Java ecosystem, but we just announced C# support, so I'll need to make sure it works with C#. Although I'm not sure if this will be useful for like JavaScript, TypeScript, and Python, because this is very much going off of like the static type information in the LST. And so any language where that is incomplete, if we cannot statically determine the linkages between what you've changed and the tests that exercise that change, it will be useless. So if you have a bunch of JavaScript or Python, even though like I could technically support those, it might be better not to, because if you're using like TypeScript and everything was exhaustively typed, you could get results just as good as this. But if you are missing any types, or if those types are a little loosey-goosey, which, there's rarely perfect static typing, even in mature and disciplined TypeScript code bases, this technique would not work as well. So I think it will probably initially at least be restricted to statically typed languages. So Java, C#, Go will be, Kotlin, of course. Groovy, not so much. Will all work with this. So if you have a build tool that you want to make sure that this supports, or a test execution plan that you want to make sure this supports, let me know your feedback, that you're interested in trying this out, but that you have something that it might take some work to support. So so that is the gist of this preview. I'm interested in your feedback on this, and hopefully we can use this to all stop testing things that don't need to be tested, and to have our agents stop testing things that don't need to be tested, and start testing things that do need to be tested is the flip side of that, right? Since like I said, I've frequently seen agents not know what all tests are relevant to their changes, and human programmers too, right? Because no one has a complete map of all of the linkages in the code base in their head. So without that, you're going off of your intuition and knowledge of the of what is relevant, and it sometimes leads to a nasty surprise later, or just a bunch of wasted time testing things that do not actually turn out to be relevant. This isn't the first tool to have this idea. This isn't a totally original idea or anything. Like there's a popular Eclipse plugin, Infinitest, I believe it is, which I've referenced to some prior art in the area. And I've seen tools that would do this kind of thing using code coverage data, using the instrumentation from previous test passes to figure out what code covers what things. But it to me, it kind of defeats the point of a performance optimization if you needed a full previous test pass in order to, make a new test pass shorter. So that's kind of why I've gone with the looking at the call graph in the code to determine it. Okay, so next steps before this is kind of like fully ready for release, and actually goes into the published version of the Modern CLI, is to I want to exercise it on some more changes. I want to kind of have a strategy around like reflective access or dependency injection, or like frameworks like Spring and Spring Boot that use a lot of annotations to do, reflective-y things to, do dependency injection, or otherwise like wire up your application at runtime. Like if we can maybe detect some linkages that are not purely there in the call graph, this could be more useful and accurate for those frameworks. And then, yeah, just some kicking the tires on it. And so if you have feedback, or if you have worked with tools like this before and have ideas, feel free to shoot me a message on our Open Rewrite community Slack. And yeah, hopefully we can all stop running tests that are knowably irrelevant to the changes we are making. Okay, that's about all of the content I have for you today. So hopefully you found this interesting and care as much about not running tests you don't need to as I do. And I will see some of you in person next week in Miami at the Code Remix Summit. I think it's probably still possible to get a ticket if you have slept on that until now. But aside from that, there will be no official Code Remix stream next week. And so I will see all of you again in 2 weeks. So thanks for watching, and goodbye for now.